Okay, welcome to the video I've put together for chapter 4.3 of our textbook. We are going to be looking at rational exponents. This section is not much different than the previous section, 4.2. So if you understood 4.2 with the integral exponents, this is much the same thing. The only difference is, right, we follow the same rules. We are going to when multiplying powers with the same base, we can add the exponents. When dividing powers with the same base, we subtract the exponents. When you're finding the power of a power, you can multiply the exponents. And those rules all still same apply. The only difference is now we're looking at rational values. In other words, we're looking at decimals and fractions. So the same rules apply. This is just a good review on, do you understand your fractions? So I got a few examples here we're going to look through. These are the ones out of your textbook. So we'll be following through those ones there. The other thing is I'm going to introduce a couple little twists, maybe not twists, but I'm going to simplify your life a little. They introduce a couple of ideas and concepts that I'm not a fan of, that we can eliminate that now, and we'll take a closer look shortly. Looking at our first example here, so if you go to the page, we are just looking at two powers with the same base, so we can add the exponents. In this case, our exponents happen to be 1/3 and 5/3. We already have common denominators, so again, as long as you remember your adding fraction rules, you're fine. So we can just rewrite this with a dead marker. Let's try the other one. So I'm going to write my base as 5. My power is 1/3 plus 5/3. We add those fractions, and we get 5 to the power of 6/3. If we have a fractional exponent, same rules as other fractions, we always want to simplify, right? If it was 10/5 as the fraction, we're going to simplify to 2. If it was 5/10, we're going to simplify to 1/2. We're going to get the simplest form. We are also not going to do mixed numbers. If we have improper fractions, so the numerator is larger than the denominator, we are going to keep it in that format. The only exception is going to be the one we have here, 5 equals 6/3. That simplifies to a nice round 2, so that is going to be our answer. 5 squared. So then the question is, did it ask us to evaluate? Evaluate means give a final answer. This one did not ask us to evaluate. It asked for the value with the exponent in simplest form, so we're going to leave it at 5 squared. For the next one here, we're looking at x to the power of 5 times x to the power of -1/2. We're going to have to follow the same rules. We're going to have to add exponents, and we can see if we can make this work. So we have 5 plus -1/2. So all we have to do is we have to get common denominators before we can add this. So 5 we can convert to, oops, I shouldn't even bother. We're going to just focus on the power, not the entire thing here. So this is going to be equal to, or 10/2 minus 1/2. I'm having a real issue just writing down values here. Minus 1/2. So then we are going to look at 10/2 minus 1/2 is 9/2. That is going to be, right, that's as simplified as it can go. We can't lower the values by the same amount anymore. And I'm going to leave it as an improper. So my final answer would just be x to the power of 9/2. Which takes us to the third example here, so C. Here we have -3/4, so 3 to the power of -3/4 over 3 to the power of 0.25. So here we have a fraction and a decimal. Now, my rule for math and most teachers' rules for math are going to be the same thing. If a question is asked to you in fractions, as above was done, you answer in fractions, as we did. Right? Asked in fractions, we're going to answer in fractions. If the question is asked in decimals, then we're going to answer in decimals. In a question like this one, if we are asked in both fractions and decimals, we get to choose one. We're going to answer in either fractions or decimals, but you do in fact get the choice. Most people for this case will go to decimals because it's easier, just numerator divided by denominator. But hopefully 0.25, we recognize that as a pretty straightforward fraction to deal with. That becomes 1 over 4. So again, I'm just writing, so I have the same base, so it's going to be 3. I'm dividing these powers, so I would subtract the exponents, so it's going to be negative 3/4, which I can plug in my calculator, which is 0.75, subtracting 0.25. Again, I don't like to put the equals there, it just confuses me with the other equals. So negative 0.75 subtract 0.25 is 1. Therefore, my answer is 3 to the power of 1. Do we need to write the 1? No, we do not. If you write 3 to the power of 1, fine. That's not incorrect, that is correct. If you just write 3, you are also correct, right? Because there's an assumed power of 1 or exponent of 1 on the value of 3. So that is how we do C. Now the first one I want to look at, so D, this is one of the ones I was talking about. This is a good question to understand, to work through, where I'm going to work through this example as is. I would not ask these of you. When you're already learning something new, I don't feel it necessary to say, here's something new, oh, and here's a curveball with something new as well. So questions like this is simplified as far as it can go, as far as I'm concerned, right? We don't have the same base. We don't have, because of that, we can't interact these exponents. As you get more advanced in math and understand things, and you start to recognize that we can make these the same base that work, yes, we can go that route. So I will show you how they did this, and we'll work through it, but don't be overly concerned. We will not see a lot of this in my classrooms. Not until you understand powers better anyways. So I have 8 to the power of 1.8 and I have 16 to the power of 0.3. They're both in decimal form. I don't have matching bases, but I can make them the matching bases, and I can recognize that. I know I can say 2 cubed is the same as 8, so I can turn this into a power of 2. 16, it can be 2 to the power of 4, so I can express this with a base of 2. So I can convert them to similar bases using my knowledge, right? That's something to keep an eye on in the future, right? If we have 3 over 27, I can convert the 27 to 3 cubed and get the same base. But again, I'm not overly concerned with that right now. I'm more concerned with the actual following the rules, adding, subtracting the rationals appropriately. So in this case here, it would turn into, and we're going to put this in brackets, right? So 8 is in fact 2 cubed to the power of 1.8. 16, right, we go 2 to 4 to 8 to 16, so that's 4, 2 to the power of 4. 0.3. Now I'm not done here yet, because I can still say multiply, right? Find one exponent for each. 2 to the power of 3 to the power of 1.8, I multiply. 3 times 1.8 is 2 to the power of 5.4. 2 to the power of 4 to the power of 0.3 is going to be 2 to the power of 1.2. And of course, then we can just proceed as normal. 5.4 subtract 1.2, right? We have the same powers, the same base, subtract the exponents. So 2 to the power of 5.4 minus 1.2 is going to be 2 to the power of 4.2, and that would be our final answer. We are going to have a similar question like this that we run into the next example, and it's going to be the same thing in my books. We are not going to worry about converting to simplifying bases. We're going to leave it as is, just to make our lives a little easier. Let's make sure we understand this before we complicate things. So I'm just going to reset the board, and we'll move to example 2. So example 2, this one will be a little faster than my explanation of the last one. It's going to be the same thing, right? We have power of powers. We're just going to follow our rules, get to our answer, showing our work along the way, right? 4x cubed to the power of 0.5. Again, with this one, we got to remember that that 4 does have an exponent of 1, and we can't ignore that. That's the biggest mistake people make, is they apply that power of 0.5 to the x, and they ignore that coefficient. They forget that 4. So don't be that person. So this is going to be 4 to the power of 1 times 0.5, x to the power of 3 times 0.5. Right, I'm just writing this all out so it's seen. 4 times 0.5, so this is 4 to the power of 0.5. X, 3 times 0.5, of course, is 1.5. And there we go. So that is going to be our answer, right? So they wanted an exponent in simplest form, that's it. But in this one, they also did ask us to evaluate. So we can use our calculator. You can type in 4 to the power of 0.5. You're going to find out that that is going to equal 2. And x to the power of 1.5 doesn't simplify anymore, so that will be our final answer. Very straightforward here. Next one here, I have in brackets, right, x to the power of 3 times x to the power of 3 halves, and that's all to the power of 1/2. I'm going to, right, I could take the 1/2 and apply it to both of these each, right, using our distributive property of multiplication, but I have the same bases here inside of my brackets, so I can simplify what's inside of those brackets first. You can work through this or take my word on this, right? 3 is going to be 6 halves, so 6 halves plus 3 halves is going to be 9 halves. So I'm going to have x to the power of 9 halves times 1/2. Again, that's a power of a power. I apply the power of a power rule where I multiply my exponents. So x to the power of 9 halves times 1/2 to multiply our fractions, right? Numerator times numerator, denominator times denominator, you're done. So this becomes x to the power of 9/4. It's an improper fraction. That's fine because it's simplified. We are done. That is just going to be x to the power of 9/4. So be it. Here we go with example 2c. Again, if you take that 16 and you take it down to a base of 2, good for you. You are on your way. I am not overly concerned with that right now. I'm concerned with just getting the other rules rolling before we start looking at that. So from this one here, and for you when you're doing your work, if you come across this, leave it. I'm going to apply that same rule. I'm going to have the 3 to the power of 4 over 16 all to the power of negative 0.75. I got that negative exponent right now. I like to clear that up right now. I know how to get rid of a negative exponent, which applies to everything, the reciprocal. So I'm going to get rid of that negative 0.75 and turn it into a 0.75 just by finding the reciprocal. So I'll rewrite this as 16 over 3 to the power of 4. All to the power of 0.75. I'm going to do what I did in the previous questions. So 16, 1 times 0.75 is 0.75. 3 to the power of 4 to the power of times 0.75. So 4 times 0.75 is just 3. Or did I say 4? 3 to the power of 3. That is my simplified exponent. In my case, I'm happy with it. That is my simplified exponent. It is in fact asking for us to evaluate as well, which means find the final answer when possible. So 16 to the power of 0.75, we can enter that into our calculators, and we're going to see that that comes out to 8. 3 to the power of 3, or 3 cubed, is 27. And that can't simplify any further. That is our answer for 2C. So again, as long as you realize I'm not looking for you to simplify these bases, we are going to get along just fine. So we only have one example left to do, example 3. I'll take you through that real quick, and that will wrap up all of what we need to know for 4.3. And for the final example, example 3, I should write that in there. So we are looking at a word problem. I'm not going to write out the entire problem on the board, but you should have your textbook open and following with if you were looking for help for this. So just reading it out though, food manufacturers use a beneficial bacterium called Lactobacillus bulgaricus to make yogurt and cheese. The growth of 10,000 bacteria can be modeled using the formula that's given on the board, where n is the number of bacteria after h number of hours. So again here, word problem. So again, like question asks you in fractions, you answer in fractions, asks you in decimal, you answer in decimals. It's asking me in words, I'm going to answer in words. So for question A, so what does the value of 2 in the formula tell me? So my value right here is 2. The fact that I have to take 10,000 and I multiply it by 2, it's telling me I'm doubling every time something happens with this exponent. So that's what the 2 is telling me. That is my base of my exponent. That is one of the key values. So the 2 is telling me that this refers to doubling time. So that's my answer for A. B is asking us how many bacteria are present after 42 hours. I don't even need my calculator after this because my H is my hours, 42. If I look at the exponent, it's 42 over 42 equals 1. So 10,000 times 2 to the power of 1 is just going to be 20,000. So the question again, how many bacteria are present after 42 hours? There are 20,000 bacteria after 42 hours. Again, so that was our doubling time, and that's we get. So that 42 is telling us how long it takes to double. Because every 42 hours, this would become a fraction of 42 over 42, which will be giving us, right, the value of 1, double. After 84 hours, that's going to be an exponent of 2, so it's going to double from what it was previously, and that is referring to our doubling time. In C, now they're actually asking us a little more complex of a question, and we're going to look at how do we enter this in our calculator. But it's saying, how many more bacteria are present after only 2 hours? So after the first 2 hours, so again here, when I'm writing my formula out for this, it's going to be that the number of bacteria is 10,000 times 2 to the power of, right, 2 hours, so 2 over 42. And we would just enter this into our calculator. The only thing we got to be careful of is when we enter an exponent like this in our calculator, our exponent has to be in brackets, right? If I write 2 to the power of 2 divided by 42, it's going to do literally, it's going to take 2 to the power of 2, which is 4, and then divide that by 42, which is not what we want. We want 2 to the power of whatever 2 divided by 42 is. So the 2 divided by 42 must be in brackets on our calculator. If we do that, then we will get an answer of 10,335.5778. I will write that out. 335.5778. Now for our final answer, of course, we're dealing with a living thing. We're dealing with bacteria, which is the same thing as dealing with people. With our final answer, you can't have half a person. So we are going to make our answers round up or round down. We're going to round our answers to make it make sense. Same thing we said, how many students are in this classroom? Well, I calculated it should be 3.3 students. You show me a 3.3 of a student, I'll show you a nice big lawsuit coming your way. So we got to make sure we're going to round this off to 10,336, but it's asking us how many more bacteria. So we started with 10,000, now we have 10,336, so there are 336 more bacteria after 2 hours. And again, right, if I can take the time on the video to write out the answer, you can take the time on your assignment to write out the answer. The last question, of course, is going to be after 105 hours, how many bacteria are present? So I'm just going to rewrite this, but the difference is, as I bumped the camera there, I apologize, I'm going to write this down how it should look in your calculator. So you're going to write down 10,000, so 10,000. You're going to say times 2. You're going to put the power button, which could be the hi-hat, the y exponent, whatever it is, and then I'm going to put in brackets, and I believe it was 105 hours, 105 divided by 42. You're going to enter it in your calculator as such. You will come up with an answer of 56,568.54, so on and so forth. Again, for rounding purposes, that 0.5 will take us up to 56,569. And again, my final answer, after 105 hours, there is 56,569 bacteria present. And that's the end of the examples there. So this one should be a very straightforward. As long as you remember how to add and subtract fractions, you know your rules of the exponents, this should be a pretty straightforward assignment. So best of luck, and I will see you for the next lesson shortly.